Hi, I'm Andrea and welcome to Productive C#. In this video, I want to talk you how you can write unit tests for synchronous code using NUnit and NSubstitute. So let's see what's the class under test. So this class is called cache and it's just implementing a sort of cache on top of storage. So the storage interface is called iStorage. That has a method save and load. So we're only using load. The given a key will return a particular value. So the get method of a cache is calling the storage load method only once every 2 times. So effectively it's reduced the number of times the load on the storage is called in order to avoid an expensive operation. And it's storing the values inside an in-memory cache, underscore cache here as a field. All right, and we use a its dictionary to remember the number of times a particular key has been requested, so that we need to decide if you want to reload or not. Okay, so let's have a quick look at the method. So the first time get is called, passing a key that is not present inside the its dictionary, we do a reload. So we call the load from the storage, we get the value, we save the value in memory inside the cache dictionary, we set the its for that particular key to 1, and then we return the value. Okay. Also, we do a reload if the number of its for that particular key is greater or equals than 2. Okay. But if the cache, if it is a cache it, that means the number of its is not greater than 2, and we have something in the cache, we simply increase the number of its and return the value from the memory. So we do not call the storage.load method. So let's see how we can write codes that test this code. As you can see, this is an asynchronous method. It's using the async and await keywords. And the method itself is also calling an asynchronous method of the storage. So NUnit makes testing asynchronous code very easily. Basically, you can do that simply by using async also in your test. This enables you to use await directly inside the test in the same way as you would use this particular cache inside your production code. So let's see the test in order to see how we can do the classic operation required in order to do unit testing. Okay, so the first test is just testing a single get. Okay, so first of all, we create a substitute for the storage. And as you can see, we can say that when load is called with a particular key, we want to return value 1. This syntax is exactly identical to the syntax used if load was were an asynchronous method. So there's no change in terms of syntax in this case. Then you can create the cache object, and then you can use await in order to call the get operation. And then you can use the received method in NSubstitute to assert that the load method on the storage is being called only once. And you can just use await in order to do that. So as you can see, the code reads quite naturally if you are C# developers and you are used to reading async and await code. And that's basically how you can write your test. So you declare your test with async, use await inside the test. You can mock calls using the normal syntax in NSubstitute, and you can use await in order to assert that a particular collaborator has been called. But it's simple as that. Let's see how the test, but you probably get the idea now. So let's see when we do multiple gets, but using different keys. As you can see, I'm calling await twice, passing to different keys, and asserting that we received the load calls with the 2 different keys, one after the other. Let's see now how we can deal with exceptions. It's fairly simple. You can say that the load method throws an exception using the normal throws_t method in NSubstitute, and you can use assert.throws_async in order to say that you expect the particular asynchronous operation will throw an exception. And then you need to pass a lambda, an asynchronous lambda, that calls the asynchronous method you want to test. So this is something that has been added in NUnit in order to support asserting that a particular asynchronous code throws an exception. Very important to say that the version of NUnit that is required in order to be able to test asynchronous code using this approach is version 2.6. Okay, and that's all. The rest of the code is fairly similar. Let's see a few other tests, but there is nothing new in terms of the syntax. This one is basically testing that we can call get more than once, and then the third time is called, we assert that the load is being called twice in the storage, and we assert that the value is different. So this is basically testing the behavior that's of the reload. And then we can test also multiple gets, passing different keywords, and then test how many times the load is being called. So, you can write as many tests as you want. This is kind of cover this method quite extensively, but I wanted you to have an example of how you can write a synchronous test to test asynchronous code. And as you can see, it's fairly easy. So to summarize, if you have code that use async and await, and it's fairly common these days with C#, you can use NUnit in order to test this code fairly easily. You can just make your test asynchronous using async task or async task T. And you can just use directly await inside the test. You can mock asynchronous method calls as you would do normally using NSubstitute. And you can use await also to verify that a particular collaborator has been called in the appropriate way. And you can use await in order to call the method on this test as well. And finally, you can use assert.throws_async if you want to assert that a particular asynchronous code will throw an exception. And that's pretty much it. So now you're ready to test any asynchronous code using async await and NUnit and NSubstitute. Happy testing!